soldering up the first prototype, C64 Saver revision 2.1, which has a mistake in it. This resistor here was rotated for some reason, but the traces are correct. You can see here that one of the traces are just stopping in the middle of nowhere. Like this one has been rotated with this fixed point, so, and you can also see at the back something weird has happened. So that happened right before I made the Gerbers. So yeah, so here you go. It's maybe a bit ugly, but you can see they are standing up in the air there. It's easier to connect probes. It was actually a bit hard to solder that MOSFET, so because it has a large mass. So yeah, maybe I'll change that, or the footprint at least. Just to show you the size of a TO220, this is a D2 pack, the right to the MOSFET there. So yeah, so this is just the SMD version of that. So you get an idea of the size. So I just tested it briefly. I haven't tried the overvoltage yet. I just turn it on with a current limit of 100 milliamps, and it seems it doesn't need that because it just draws 8 milliamps here. And you can see it's lighting on the output. I have a short circuits. Yeah, because I moved this together. So what I was going to say was, this is just an indicator with it. It has a resistor inside, so you don't have to limit the current. So I have the iPad upon a little cardboard box. So let's try it again. Let's try adjusting here. It's supposed to cut, but it doesn't cut. So something is not right. So there will be some debugging. So yeah, so I will check pinouts, see what's wrong. I have a couple of components there. We have NMOS transistor, and we have and the TL431. So the pinout can be different. So yeah, so you need to check that. It can also be the MOSFET, which is incorrectly wired. So yeah, so let's have a look. I will just try and probe around and see what we get. So yeah. So what I'm going to try and see if this TL41 is outputting the correct here. So this is measuring the input, and then when the input goes over the threshold, this one goes down. So let's have a look. The ground probe on ground this time and not the wrong one, so it should work better this time. I cut the clip there, so you didn't get that actually. So let's see. 4 volts, that's the output when there's no cutoff. So let's increase it so you can see getting closer to the cutoff. There, it goes to 1.9. That's correct. You would expect it going to 0, but these devices, they go down to 2 volts. So it's a bit weird, isn't it? So, and then boop, it goes up again. So you can see the switching point is around there. Also, there's something weird about the hysteresis. It's like there's no hysteresis at all. 5.43, and it drops and goes 10 millivolts back and it goes up again. So it's supposed to be like 60 or 80 millivolts hysteresis, but there's like 10 millivolt, not even that. So yeah. So but anyway, this part of the circuit is working. Yes, I'll try this. Let's see. See, 1, 2, 3. Okay. And the datasheet for this component says also 1, 2, 3, so that's correct. 2 and 7000. But mine says 2, 1, 3. So these two are then flipped. So maybe I looked at another component. Anyway, I will just flip these two around and try again. Don't know if you can see it, but you see I have moved pin 2 to 1 and pin 1 to 2, so it will be an easy fix, I think. So I'll just push it gently down. So let's have another go. Alright, turn this one on. So it's measuring the output of the transistor. So let's see what happens. Something is happening, but not what I expect. It's supposed to cut, right? It does cut, but it doesn't cut the output. Oh, something more is wrong. So I'm finding some problems. The wire I have here is just a 4K7 resistor. So what I'm trying to do is to pull this point up harder than just these two guys here, because if you look in the original document, well, that's not a good explanation, but I removed this one because I didn't understand the use for it. I used it to move from this point over to this point instead, to make it as a hysteresis. So, but we need those hysteresis, but at the same time I think maybe 20k is not enough. So what I saw here was just a soft cutoff at the threshold. So if you look now, so if I move up, you can see, boom, it goes straight up. So what am I actually measuring here? So I'm measuring exactly here. So that was what I wanted to see. That this point goes straight up to the supply voltage when the sensing circuit triggers. So, and it didn't do that because of this weak pull-up. I think there's some leakage here somewhere. So yeah. So I ruled out the transistor, but now the transistor is broken. But we have another one, so no problem. Also, there's a third problem here. This one is the wrong way. You can freeze frame here, make all the changes on this board here until I'm happy with it, and when I'm happy with it, I will change the schematic. So I will add the component that goes from here and up there. So basically I think I will drop this one. The only reason why I have this is to protect the gate here from having an overvoltage current condition, and then I mean really high overvoltage if you get a spike. So what can happen is that you get it will be protected by this one, but you need to current limit it, and also we have a path down here which can kill this one. So let's say it goes over 14 volts, then both this one and this one is turned on. Say there's a breakdown here, but we have protection, so that shouldn't happen. So that's the the main feature of this new circuit, is actually this one. It should make them not die like before. So R4 is back in the hysteresis resistor, and we have a output measuring here. I also said that this one sucks, but you get what you pay for. It keeps falling off anyway. So yeah, so let's see, show you what I mean by snappy performance. So there you go. So if I now move to 5.49 and then 50, bang, you can see it jumps up straight away. But then you have to go down 50 millivolt to get it off again. So that's the hysteresis. So you can see that it's much more decisive now. So if there's some noise on the line. As you can see, I'm trying to simulate noise. It won't go on and off. So yeah, so that's part of the circuit is now fine. I put it on GitHub so I don't forget what to do. Now I want to put in the MOSFET because I want to test that it actually works. Now the MOSFET is in the incorrect way, but it should work. The only problem I have is that the output will not go to 0 because you have a body diode here, which will turn on at not sure 1 volt or 2 volt. So yes, you can only drop it to like 4 or 3 volt. If this one is 5 though. So let's say it's 6 volt and it goes to 5 volt. So that's not a good thing. I have a resistor from here to here now. That's the wire going here. So that works. But I also want to test if I remove this one because I have limited space on the board. God damn it, what's up now? It still works, like you can see it flips there. But the output doesn't turn off. Why? Weird. Still not working, what the heck? Now I'm measuring over D3. D3 will be like the gate source thing here. Is correct, over the gate there. You can see it goes, it's supposed to be negative because it's PMOS, and then it's supposed to shut itself off here, and it does. Still off though. It's a bit weird that it can continue to follow, but the output is still on, so what the heck? Oh, this is really spooky. Why the hell do I see a diode drop from 5 volt to 4.3 from the input to the output? And I have turned this around, this transistor, to compensate. So what's wrong? Oh. By this time I moved over to swear words. Okay, let's see. There. Switched off. Okay, let's see if you can see it. I'm moving around the set point there. The output is switching. So what have I done? Well, I broke the first transistor when I tried to remove it to try a different setup. And then after that, look, yeah, now this one fell off again. Stupid. And then I switched to another transistor called 2405, and it doesn't really say. It says here that it is an NMOS, but it didn't say so in the datasheets, but I should have seen it because it's supposed to be negative values for PMOS. And then I have these large ones. So yeah, this is the one. So this is RRF 4905. So that's a PMOS, really powerful, and 20 milliohms on resistance. Just plugging it in the reverse, actually, that's what I'm doing. So yeah, that's good news. So yeah, that concludes this video. I have ironed out all the bugs and pushed the changes to GitHub, and the changes are basically pin 1 and 2 on Q1 was rotated, Q2 was reversed. I need more pull-up on the drain on Q1. R5 in the circuit is now repurposed as the pull-up. And the video shows that I have tested it also. That's cool, and you can also see the schematics if you want. So just to conclude, the MOSFET is the correct way. R5 is now pulling here. This one has been swapped with a 2N7000 component. I didn't know that KiCad had this. I had the generic one. Now it's 1, 2, 3, so all is fine. I have moved out all the Gerbers, which was together with the source. I don't want to have the source and products together. So what you have to do is to get out of here and click releases. Then you will find Gerbers. There's also a Gerber down here for the add-on board. But the add-on board is not tested yet, so I wouldn't recommend getting that one yet. So yeah, so thank you very much for watching. So, and see you another time. So this will be the next board.